ERC20s. Miguel.
Yeah, well, what the hell is an ERC20? I have no idea.
Of course you don't. ERC20 is the token standard for a fungible token. So fungible is a bad word.
Let's describe what a fungible token is, because it's an ugly word and most people don't know what it is.
Yeah, it's just remove fungible. It's a token. You're done, right?
Yeah.
Fungible means that all parts are equal. So, like dollar bills or euro bills or whatever. If you have $1 bill, you can safely change it for another dollar bill because they are worth the same.
Yeah, it's exactly the same. So you have $1 bill, I have $1 bill. We can swap it, and we are just exactly the same. So that's the fungible concept there.
A token is a fungible unit of account, usually, right? So
regular tokens, right? Because NFTs are also tokens. But when we are talking about transferring some coins somewhere, we are talking about fungible.
Exactly. So the difference is that a regular token is fungible, and NFT has to say that it's non-fungible because they are actually non-fungible, right?
Yeah, because let's imagine in the gaming industry, talking about a couple of minutes ago about the gaming industry, and you have several items on a game, and magic boots are not the same as regular boots for the hero, right? So they will cost different. No. And they will cost different. They will have different costs. For instance, this is an example.
I don't know, because I never wear the
swapping. Magic. Yes, so swapping those won't be the same, because one boot can cost $1, the other boot can cost $5, and if you swap it, you don't get the same thing. So that's the non-fungible example that I come up to my head right now.
I was doing a walk in the nature back a few hours ago, and I could use magic boots.
Yeah, you didn't have one. So you would pay $5 for magic boots, but you had regular ones. So it's not the same. Those two different tokens are not equal.
Yeah,
they are not swappable.
Exactly. So fungible token is, our ERC20 is a fungible token because of that, because all the units are equal, right?
Yeah.
In value, they represent the same, right?
Yeah. Okay, let's talk a little bit about the standard. What can we get from the standard?
The standard gives us an interface that allows us to own, transfer, do the basic stuff, know what is the circulating supply, the total supply, not the circulating, the total supply, because in this case it's the same, and know the balance that each owner owns of the token, and send it to other owners, and that's it.
Yeah, in the meantime, I do have a few questions for you, because I don't really know the answers. So one of the things that, that comes to my mind is, no, because I'm the dumb guy here. So keep up with me, and we'll get through this.
Well, how can we handle these guys' questions?
These are really dumb questions that I'm going to make, but they have some. They have something. There's something in these questions that can be useful. So why are most of the tokens defined with 18 decimals?
No idea. Who is the dumb now?
because I don't know. It's too many decimals for me. And if I'm managing a token, why the hell do I need 18 decimals? Well, mainly because the tokens are really low value. But if they remove the decimals, they would value just the same because they would require a conversion to whatever token.
Let's think about why Ethereum has 18 decimals.
Yeah, why?
Just because they can.
Yeah,
right?
Well, they could make 20 or 32. I don't know, but
it's like this.
These are two questions. 9. Why so many? Why so many decimal places? And why 18?
Actually, let me check. Bitcoin has 8 decimals, and the unit is the 9th number. So Vitalik, when was deciding to implement the decimals, he maybe thought that probably Ethereum will be
twice as good,
less expensive.
We are twice as good, so we have
more expensive, and we need more decimals to address low values. Because actually it makes sense, right? Because let's think about the value of Bitcoin, right? At 100K or 1 million. If Bitcoin gets to 1 million, you will just have 2 decimals for the unit of dollar, right?
You lost me there.
It would be impossible to buy things in Bitcoin that cost less than 1 cent. So this is a possible problem eventually for using Bitcoin in regular micropayments, right?
Yeah.
So Ethereum needs a bigger number because probably when Vitalik and the team were deciding on this stuff, they agreed that probably Ethereum will have a market cap larger than Bitcoin because it's the world computer. It's blah, blah. Now Bitcoin has clearly advantage on that, but Ethereum was made in 2014. So Bitcoin didn't have the store of value idea yet, right? It was just a coin, right? So
they were playing safe.
Yeah, they were just putting a lot of numbers there, and they came up with the 18. God knows why, right?
Because they thought they were twice as good as Bitcoin. So they
not twice, it's twice and more, because if it would be twice, it would be 16, right? So
yeah, right. Yeah,
they just just made it.
Okay, they went for 18. That's totally fine. But
and then every other token,
they went behind.
Don't implement the decimals function, and they are all 18, right?
Yeah,
because they are already implemented in the token standard by OpenZeppelin and some others. So
and defaults to 18, right?
Yeah.
Probably
people are too lazy to change it.
Well, I don't know. And I mean, from my perspective, it makes the readability much harder when you have a lot of decimals. So yeah, that's the thing, and it wouldn't change the value of the token if you reduce the decimals.
You can always make an expression for that, like 1 to the 18th times whatever.
I'm going to make a proposal to stop people from.
Actually, Ethereum has Solidity language as those helpers like 1E18 or Ether or whatever. So you can have some more readable numbers.
Yeah.
But well, let's go.
Well, let's go to the next one. Okay. Why do we need in OpenZeppelin? Why do we have the ERC20 metadata?
The metadata, that one is hard.
It's that interface that has the name, the decimals, and something else.
Let me check.
And the symbol.
Let me check one thing, because I don't know everything by heart, right? I am being surprised with questions here.
Oh yeah.
So, but metadata is already, I think. Let me check. The ERC20 contract also has the metadata.
Yeah.
Right.
Why did they split up in open?
I don't have any idea. Probably because they wanted to create smaller interfaces, and they decided that the metadata is not used by everyone, so they divided it in a different interface, and the contract implements them all. I don't know.
I did have a supposition for that, but it doesn't. It's not that. I thought at first because they would implement the same thing in ERC20, but the metadata is different.
It's different.
And I thought, well, they are splitting this up because it's the same interface, so that they don't have to rewrite the interface.
And it's a little
that we can just ask the interface they use that. I don't know, but then those interfaces don't match.
And it's a little bit misleading, so that's why you question it probably. But yes, the question is the real answer is I don't know, and the more helpful answer is that probably they didn't want to have a huge interface, and they divided it in several so that people can use it if they really want it.
Right? Okay, I'm good with it. What is the total supply? And I'm going to ask you this. I'm going to say why I'm asking this, because in my view, the total supply should be a fixed number, but it's not.
That depends.
Yeah. In my perspective, when you launch a token, the total supply should be fixed, but you can mint it and you can burn it. So let's go talk a little bit about this. What is the total supply?
That depends on the use case, right? You have tokens that have a fixed supply. So when they are deployed, they mint a certain amount of tokens, and the contract is not mint, doesn't use the mint function. So the mint function is only called in the constructor, and the tokens are sent to some holder, the initial holder, and that initial holder will make somehow the distribution, and that's it, right? You have tokens that are mintable and are claimable, for instance, from initial holders that have some kind of white listing or something like that. So you never know how many will claim, right? Because some people might be eligible to claim airdrops, but they forget, right? I've done it many times, and then I want to slap myself in the face when stuff goes bananas. But that happens. Shit happens, and crypto is so has always a lot happening. We cannot follow everything, right? It's impossible. And you have also tokens that have inflation, right? And inflated tokens or tokens with inflation, they don't have a fixed total supply, right? They will be minted every time some event happens or something like that, right? So there are many use cases for tokens, so it doesn't make sense to have a fixed supply in a token. It can change. That's why we have a mint function or an underscore mint function that is not part of the standard, but we can actually export it if we want, for people to be able to mint, or to owners be able to mint it, or whatever, right?
Yeah, well, I would figure that when you do something like that, you would have different pools, and for instance, the inflation would come from a specific pool, and airdrops would come from another pool. But you would create all the pools when you create the token. So that was my supposition.
Yeah, you can do it, but you don't have to, right?
Mm-hmm.
And the standard is able to account for the supply for you. So, and actually it makes more sense because, for instance, if you go to a token in Etherscan or something like that, and you see that it has 1 gazillion tokens, you will understand that, yeah, probably each token is not that expensive. And then you go to the market cap, and it's $1 gazillion, and the market cap is based, or the fully diluted market cap is huge, but 99% of the token is not circulating.
Mm-hmm.
That is a very big problem, right? Because, for instance, they minted a bunch of tokens, but they only have 1% circulating, so that people are trading 1%, and they are valuing a token in $1 or $2 or $100.
Yeah.
And then the total supply goes to a number that you cannot understand, right? And that is one problem that we are having now with exploiting that reality. That's why sites started to show the fully diluted market cap everywhere and so on, because people were playing with mathematics there, and they are still doing shit like that, right? So they launch a token with a very small circulating supply on exchanges, so people that start trading it and having outrageous demand for it, because it's a very small supply, and then they rug pull everybody, because they just put out the other tokens when they can, and everybody they play the central bank scam, right?
Yeah, I mean that's also the problem with minting, right? You can mint whenever you want.
That's why it's important to check the contracts whenever you want to use certain projects or certain tokens. Go. That's why there is a Etherscan contract tab that you can see the source. And never trust a token that the source is not verified, right? And it's not there. Because if it is not there, it's probably not in your own interest.
Yeah, it's because they want to hide something.
Yeah. Because tokens are standard, so there's no
we are talking about
intellectual property around that shit, right?
Yeah, we want to. We are talking about serious projects, not if you're putting your little game online so that you can play yourself with your smart contract. Well, you don't need to put it there, but if it's some financial thing, it's if it's something that may take your tokens out.
Yeah, if it is to be used by others, you have to put it.
Yeah.
Every time, because there's no reason for you not to. And there's a saying in crypto: don't trust, verify. And that's the way we verify smart contract. Is going there and inspecting the code. And if you cannot do it yourself, ask someone that can
probably
inspect the code for you and tell you what it does. Right?
Okay, I'm good with it. Let's go to another question. So how does it work, the transfer delegation? By delegation, I mean, because you don't have to transfer stuff yourself, you can allow a third party to make a transfer on your behalf. So how does that play out?
The idea is that sometimes you don't have to be in control or in strict control of your own money, like in your bank account.
What? Right? I'm not in control of my own money? What the hell?
No, in your bank account, you are never in control of your own money.
Not in my bank account, but we are talking about blockchain. It's my funds. How? What are you talking about?
But there is something useful in not being in total control of your funds, because, for instance, when you receive your electrical bill and you allow the bank to pay it for you, you never miss the payment deadline, right? That's cool. And that's something people like, right? For their scheduled payments to be done automatically. I don't, but I am an old guy, and I've experienced so many shit banks did in the past with direct payments that I don't use them. Maybe because we are a bananas country here, but I don't like that. But anyway, people do like it sometimes, and that's a functionality that it would be impossible to do in blockchain, right? Because in blockchain, you are in control of your own funds all the time. So the standard, the ERC20 standard, implements a way for you to delegate a certain amount to be possible to control by an external account, right? So you say, okay, I have 10 Ethereum in my account, and I allow Miguel to use 1. And then Miguel tries to use 2, and it won't allow him because I didn't allow him to use 2, but he might use half an Ethereum one time and another half next day. That's it.
Yeah. So
the way to do it is I approve Miguel's account to control a certain amount of my balance if they want, not that they have to, right? And they use transfer from my account anywhere. Can be to their account, can be to
some other account,
third party, or whatever, right?
Yeah, and that is quite useful if you have a managing system that is making the transfers from one entity to another. So we are talking about 3 different entities, and you have this manager entity that may transfer some tokens from one account to another. So yeah, and it's not like only two parties, like me and Pedro, that Pedro allows me to make a transfer to me. It's a third party that Pedro allows that third party to transfer from his wallet to mine.
Yeah.
So this allows this triangle
allows a multitude of use cases. It can be third parties doing mediation. It can be many things, right?
Yeah.
Okay. So
I'm done with questions with the ERC20.
Okay. I think we are done with the ERC20's most exquisite stuff. And now we are moving on to